Do you have to know how many with the same margin was for Garfield and Electoral College and that sort of thing? Did you manage to reconnect? Fine.
Yeah, it's not accepting my input because I don't know what to type.
Oh, okay. Oh, great.
It is time for this to end.
Right.
It went on.
What's the difference?
You can actually
Okay, Ryan is asking about the that. Is this great Renacle Institute for the last phase course of material?
Ooh. Excellent.
Okay. Are you?
There's the one student's trend. This solution is happening. We have 160,000.
Yeah.
I want to deal. Who want to like? Who
Principal investigator. Oh. You'd be using 2.7. You could be using 3. Okay. So the programming one strategy for trying to query differences in standard English languages would be to write a big if and else, and the language is English. What's on here is there's a functional srf time in the time library that allows you to pass a string that represents string and get a formatted version of the current time. So the format string I have the format needed 24-hour time or 12-hour time, and then different queries we call the query function in the 3 cases to get back a letter or two, which that's the 24-hour format or the 12-hour format. Okay. In your code, you can do that. The get and indeed English, French, and Spanish, and try Italian. Well, so again, the problem with this if-then strategy. If you're writing ifs in the code, you take a very close look at the code, and there are you're doing things correctly. Typically, ifs are a result of trying to distinguish amongst the family of resemblances. It's a problem for maintainability because if your family changes, you have to change all of the codes that are clients to that family. If you add Italian and this is both for 200 points in the web page, becomes an 8. So the programming through object-oriented strategy is to use something called dependency inversion, which extract class paradigm that everybody, I hope, sees in their first or second job or C# or C++. Of course, you find a prototype class that captures in a way that allows that capturing to be specialized. Okay? What all those queries have in common is that their get option function that has an input to full query string and turns the option. Because there is no need to vary the option method, there is no state data that persists. You ask the query, you get something back. I have get option set up as a class method and inheriting from the abstract in each of the 3 cases. This AB meta is a class that controls the behavior of another class. Python supports a feature called a meta class. Just as classes control their instances, meta classes can control classes, so you have control at one level up. I've read some instances of meta classes. They have a couple of interesting uses. In the Python library, generally, what meta classes give you some of the features that you can get in compile time but at runtime. For example, specifying that a class is an abstract class, saying you cannot instantiate objects directly from a class, but you have a subclass and instantiate subclasses. This is the purpose of the ABC meta class. The things I've read on meta classes said, apart from some of the standard use of classes, there aren't places where you really need the power of class to get in and to design a model for a particular program. I've talked with a couple of people. A mess might be useful, for example, if you have a bunch of related classes, and all the related classes have to have a special print method of sort. The meta class could be set up so it automatically drops the special method into all of your classes. But I don't have meta classes in my notes, and I have not taught meta classes because I've just not seen that of the need for them in the problems that I've solved. But a feature that I think that is worth mentioning that is in the language, the feature shows that a couple points in Python and ability to you can't instantiate directly from the class as well. Okay. So in the B version of the logic, again, I have my abstract-based class. I have variants of the abstract-based class, and that I have a 4th class that does not inherit from base class. Just to show that there's the best techniques matches. People to do is to grab the 3632 through 33, try them out, and what you should is the same output that you, or comparable output to the last series of examples. but a law structure that will make the code easier to maintain in the long term. Pick one and pick one. There's a lot of people. John, are you with what you're seeing here? You were on board with what you're seeing here. Patty is going on making sense to you.
Mine said, I must have missed something.
With
The two options theory.
that, and you should be getting that error for your account.
Okay.
And the reason you're getting that
Oh, because
because I have an assertion. I put an explicit check, an explicit type check in. Without the type check, if I grab the second line get time and do the type check, that type check is the sort of check you would get from a compiler, right? Get ready to run and just time the RTF time and see what happens. Okay. So, I said last time, at the level expression level, type in the form checking this the subclass of a particular class object is an instance of a class or an instance of a subclass in particular context. All those that are hardwired language are not an interpreter. And it's making sure that whatever you are passing as a class is consistent with family of classes that you want to use. You have to do the check yourself. You will not get this check from the compiler. And I showed that right here in this last statement I went through where I did a time strtf time. And I think that what I want to do in my notes, I'll version of notes, I'll put a comment to that effect because that's the thing, that's one of the points of the example. On 36, note also the explicit check for class. For subclass, that's relationship. This is the automatic in compile languages. It must be done explicitly if desired. It must be explicit interpreted languages. and bypass the check if we wish. And pro and that will be in the final version of these notes. Okay. And we've Patty. Since that error, that assertion error that Patty noticed, popped because there is in my code an explicit check for a class-subclass relationship. Again, sort of check you would have in a compiled language. Okay. And you can bypass that check by not doing it. Okay. And me to the final a final series of symbols. Oh, maybe this is the wrong place. That's okay. That's in the bypass. Again, hopefully, well, at some point you may find it useful as a reference. Okay, note the bypass. Note the check. Okay. The authorities that I've read on Python say that the sort of extra typicity that you get in language is useless. Even the proponents of typing strong will tell you that if you have two names in two decks, the names don't necessarily equate to the same thing. Or the term forward shows up in a lot of different sports. Your forwards in hockey, your forwards in water polo, forwards in basketball, I believe even forwards in soccer, but I'm not sure what they're called. I'm not sure. I'm shaking his head. Okay. But the term forward is one that shows up in a lot of different sports. But have different measures of performance in different sports. And a forward entity in basketball is just a lot different standards the forward entity in hockey. Some strong typing will tell you that if you're up a sports program, they assign one type of forwards in hockey and one type of forwards in basketball, and that prevents a program from, say, confusing I don't know hockey enough to be able to pick out the name of the forward off the top of my head from, say, LeBron James. Accidentally mixing statistics. What the Python and interpretive languages community is nonsense. The judicial choice of names. You can't treat a name of an entity as its type. So if you just screw up and have two different things that both have a forward attribute and confuse the forward attributes, well, probably the program will break anyway. And the extra head that occurs from having essentially two disciplines, a name discipline and a typing discipline. That got rid of by conflating the two and simply use the name of the thing as type. I'm going to make people. Bobby, am I And that particular strategy, that particular philosophy leads to a typing approach that interpretive language communities refer to as duck typing. Okay, duck typing, the famous latent typing. What is it? People call it duck typing. Duck typing is if it walks like a duck and it talks like a duck, it's a duck. It quacks like a duck. So, example 3 is the duck typed version of the code, and only changes in one place. One place is I drop the assertion from GetHub, and I'm going to say if a querier has a get option method, then that method will do the right thing. I don't have that the querier is an instance of my class of classes. And I'm asking you to take the time to run because in fact we just did. Run this code will happen. Query in Italian will work just fine, even though query in Italian is not descended from two-option query. And it will work just fine because query in Italian has the get option method, and the option method does with the context expects. Okay. Have any questions about the latent type? The sense in the Python community is that you are really a fuss budget of detail and want to make sure that your type, your logic type safe, you can always put in your own assert type, like I did in example 2. So I'm not doing for or against either viewpoint. What I'm trying to do is enter 2 viewpoints. So my own, if you had me down on it, is that I still like on typing, but I see the further languages community point. The eligible, the less clutter you have in your code, the easier to do. So let me go to the next topic. Doc talked about this series of examples before. I'll show you. I mentioned it's really Python library. Doc is not built in the Python library. The doc test is Python with the JUnit is to Java and other CPP and the any classic tests in some of the more mainstream languages. Personally, doc test is a lot more elegant than the NUnit framework. It's best for both. The idea of certain Python is the first string that goes after a F statement or a class statement. Is treated as essential and significance by the doc test library. The doc library will parse the logic and essentially formatted lines in the logic as unit tests. It's a series of unit tests. So let me talk through, and I'll have you write. Okay. So I put together a rather small example to show stuff. And something called powers of 2 that generates successive powers of 2 starting with 2 to 0. And notice what I have here is generate. Okay. And here does, we'll show you how to construct a generator. And that's the last examples in the series of examples. Notice, as per many results, the use of a yield rather than a return. And again, it's between a generator and a function. A function always starts over from scratch. and a iterator has a memory of where it left off. So if you yield, you come back into the function at the where you left off process, meaning your variables are kept safely. Next one, the first time in, you get 1. The second time in, you get 1 times 1. You get 1 times 2. The third time in, you get 1 times 2 times 2. The fourth time in, you get 1 times 2 times 2 times 2, and so forth. Okay, so this string doesn't give anything. It just, here I am. And if you will see, if you say powers of 2 dot underscore dot dot underscore, you get that. The second string is the inference symbol. What is there are embedded commands that this library will do for you. You ask it, and your life behaves as it should. So the way I did this, I have a first, which is brief description of what it does, a section that's careful description of what the routine does, followed by a series of almost columns, right? Expected response, call expected response. A fraction. I expect a type error with a traceback. Test a string in a particular mode is smart enough if you use a dot dot dot. Simply look for keywords and to say that the test failed as expected if the keywords are present and the exception that you're getting is the exception you're asking for. If you try to start with -1 or 0, you get nothing. If you try to print the first power of 2, you get 1. If you try to print the first 5, this is what you should get. And how do you work? What I do is I copy the generator function. Run it once, twice, run it 3 times, run it 4 times, run it 5 times. A special routine that's next to the sequence from the generator. So I want to copy from line 3760 to line 3796 and try this that much. And your last 2 lines should print out the doc strings for you. Yo. The doc strings. print button. 1 second, Patty, are you getting the dog strings? Ryan, did you get the dog strings? Let's see the one. Next, I can look over your shoulder. What it looks to happen is that that hasn't worked correctly. That would print strings. And again, Python convention, the first quote, if there's a first quote inside a routine, the Python def statement in class as well, set that first quote and assigns that first quoted string to the attribute double or double. What we do is to try line 3008 through 3813. Is that working? Excellent. Is that working? Okay. Comment about that real quick. First of all, I wanted to have 2 comments. Here's one. Okay. And with Notepad, what is currently done, and here's a Sudoku solver that together is an assignment for Python class. What's currently done? There you go. Okay, then I just show it. Okay. We'll put a bunch of code. I really ought to do it in one because this is fairly important. And what people will do is they'll say if double underscore name equals main. I think double underscore main. I'll have to check this. 50, and then a bunch of logic. Okay. And with that mention, is whether a model, whether a file is being run from the command line or from within the interpreter. Running from a command line, then the name will be main. And a standard tactic in testing is to name is main, run the dog tests here. So that if you have a module that's not executed but imported, if you run that module from the command line, it does the unit testing that you want. And unit testing, I became a strong believer in tests back in 2003, where I put together a 12,000 line Python compiler that had 12,000 tests. And what happened is I went to make a change about 3 months into the project, and one of the tests broke. That what I was doing was sound, and eventually letting my pulling back on was I was trying to do. So I do think that unit testing really does have a value. It's worth the price you pay in terms of taking time to construct the tests, and I'll try to do something that I'm show you modules. That idiot is useful. So yeah, what I get to do, if you have code, start this off the code. 124.8.16. Go something like 124.8.12. Okay. Pick up the and burst in powers of 2. Try rerun the 2 tests you just run. And that if you're looking for 12 as the 4th power of 2, that you need to back and do some remedial now. When you have the failed test. Did you get it all right? Join the pit. Work. Patty, did you fail? Why did you fail yet? Almost.
Really close to fail.
You didn't fail. What was the player's confusion, Shaquan? How can they help? What I did, I went to line 3787 and my notes between 16 and 12. And then this was back on. I left the powers of 2 as it was. That changed. I did the same first in powers. The problem is the question of how I need to read the beginning. What to do is start from 3760. You have to import doc tests there. All you really have to do is import doc tests. Start from 3760 to work. To work, John. To fail. Okay. If you start at 3760 and go down to 3813, it should work. And then if you go back and change line 3787 from 12 to 16, it should blow up. Did you get it?
Yes, I'm not sure.
Okay. Okay. The TV button to blow up. Yeah. The TV button to break. How do you get it to break? Sorry?
And thought,
Okay. What I wrote about the doc test is that it should declare it. here's the output I should get. Here's what I run. Here's the output that I should get. Okay. And while she's getting his to come up, and the point action flags are a list is often specifically what I invoke to dot test to do a pattern match on exceptions rather than a character by character match. If you go into the dot test library, there's a description of different options you can get out of dot test. What think of the particular segments here are the high points to look for. If you go back and you study Python in more detail, this is option one I found particularly useful. I think it's probably good with all this, right? Because there has been no feedback from date whatsoever. Nothing goes down or I don't understand you, but you trying to say.
I think he is perfectly okay. Or just completely off.
Electrical. By the way, is an important dog test. Need it until you get to 130.
Almost like
I should take a look at your columns. Give me just a minute. Let me see if I can get back on.
yeah. And that's
Oh, the last two. Yeah. Now start right at the top. Right at the top. That all that yes. Yes. You want okay. Now that's now drop down to the dot test one. Grab those ones. Go to the next one. Notice that in mode, I'm saying for both. Dot test, if your test pass, you get nothing back. Scroll. Notice scroll a little bit more. Now scroll. Scroll down. So we have to do is go back to the dot test example. So scroll up and change the 16 to 12. Okay. Right now. Come back. We already scroll up. Pick up scroll up and pick up the print first in order to do this. instead of pilot 2. Hasten and try running the slow down further. Try running that first side test one. Those see if you can tell you the step. Thank you for calling. You see what's going on with the doctor. Okay, so again, the beauty of dog tests is that you can code response, action response, action response, action response. Drop that code into your comments, and you now have the units right where they need to be with the routine. You're documenting what the routine is expected to do, and have a way of executing those tests automatically. Okay. If people see with that sequence of examples, the next in Python to show is for doing serialization. Okay? Serialization is the art of taking a snapshot of an object related to ways typically of doing serialization in the languages that I've seen. Way is the compact way, where snapshot is binary. And you're binary, and you're picking the thing up again in binary, reloading in binary. That serialization is also called, I had in my head just technical crap. It's distributed in an environment where manifests will come to be 5 minutes after class. Well, it's like checkpointing, but there's another term for it. I can't remember. Right. And so the idea is you take something and you patch it up, and typically you ship it over to partially. Thank you. Modeling tends to be binary. It has a library routine for doing the binary marshalling of objects. It's called pickling. I've never pickling because I've never had it. It's something. What I've used with instead is the ASCII version of modeling of serialization. It's grepper methods. And they're not with grepper methods because being able to snapshot and read your snapshot is really, if you're developing a fairly complex piece of logic. I was working on my compiler where I didn't know what the compiler was doing for me. And I put a statement in, and I said, generate a representation, a reference of the, and it came up with this big ASCII thing that I then eval and get back a piece of binary data that I could query to find out what the different pieces were. Okay. So Python, the approach that I've used for debug-friendly serialization in Python, I begin with a class that looks all content that can vary to the instance. I don't have a class variable that gets changed over time. I argued a couple weeks ago that having a data value that's global to a bunch of instance classes that can change and add a couple of them anyway. Okay. So any state that can change is locally instances. An init method allows you to everything in instance. That's the use of keyword parameters, whatever. So by init method, allows me to load up all my data in my class instances. And the wrapper method to dump ASCII. Typically, I use a print with the :r qualified. And out an ASCII version of a class content. And finally, the EPU method, as our time, really needs to do behavioral equivalence rather than same memory location. So without further ado, here's an example of a class definition that fits my requirements for an easy-to-dump class wrapper method. So what I'd like you to do is to grab lines 3888 through line. Let's go down to line 3901, 38 to 39. And when you get this to work, and then I'll go through and I'll relate the comments about what I think is to the code that I'm showing you. That's right. Should call to run. You should get it on true. Don't want that to run. Patty, to run if you get a final true. Bobby, did you get that to run? Patty. You're in the wrong place. Let's come down here to this time. You're way out.
Oh. I accidentally hit enter on this instead of this, and I got a bunch of codes. I think I open it again. Fine.
This is where you need, where I want you to be right there.
Okay.
Right. The whole job to about this comment. And down to every. Yes. Is that working for you now, Patty? Let's say.
Yeah, I did.
So let me talk this through. Define a class, my class. Instances of my class have two instance variables. Okay, and have two instance variables. Instance variable 1 and instance variable 2. The init allows, actually requires the user to define both of those variables whenever the class is initialized. If third variable that didn't have to be there for all instances, I would always set that up as a keyword parameter, and, or as a star IV3.
Could we have mind about this
Self serves to the instance proper. You think like self in ++ where you have a special thing called this. I think this Java equivalent. Does Java say this? Does anybody know?
Java's this.
This, okay.
This.
Okay, the difference between Java and say a C++ and Python is that the compiler in Java and C++ implicitly sticks this in front of expressions for you behind the scenes. And you only have to say this in cases where you really have to disambiguate. And when you say self or you say class, you always specifically have to name what instance you're working with. And self means current instance. And when you go to class, the current instances, two instance variables get the parameters. The method generates a string of the form class with the variables, where this use a special formatting convention that recursively references them. So references. A diction has a reference. Here's output, the two variables with the refer methods in a you're juxtaposing them with the constructor. And it says self.class.name, I could have simply said, quote, my class. I could have written this as, but that's that. If I ever wanted to change the name of this, I would then go back and change that particular parameter. I've also overloaded equals to say two instances of my class are equal if they're both my class and have the two instance variables. Okay. So notice what refer gives you. Refer gives string that is named as I used to set up X. Okay, and this one on the side. Right? Go to evaluate the string. I then object that I started. I have in effect dumped the contents of my object into a string that I can then read, or if I want to evaluate in order to do a state check at some point in my program if I must. Does sense to you, Bobby? Has the insight, does the potential usefulness of this technique make sense to you? John, does this make sense to you? And in fact, it's a way of snapshotting an object. So you get a string picture of the object that will convert back to what you're snapshotting without. Right, it sense to you. Now, limitation. I like the limitation. I'd like you to run just first begin by taking lines 3903 to 3910. yes, is that the rest limitation. You can reparize data effectively, but you only reparize code. What you get out of reparize code is an informative message telling you have a function in a particular memory location. Do any good in terms of equality testing. And here are more points like that. Let's grab next lines 3911 through 3916. Notice that we try to store functions in this and store it again because it's actually the testing for the equivalence of two functions is something like the complexity on the order of 2 to the 2 to the n, or n dice to the function. If it's hyper exponential problem. And finally, you can't do it. Graph is in depth. Okay. But with that limitation, you can't reparize code. I represent this to be a fairly powerful tool when it comes to snapshooting and debugging on code. Continue before I think nested iterators and examples of elegant codes I have in another file. And then the thing is, I really got to take some time to show modules. It won't be this week, it will be next week. If I do show modules, that will close things out. Okay, and this class is in Python. Before I go on, Ryan, any questions or comments about what I've shown so far today? Shaquan, any fun questions or comments?
So it's defined by
Okay, just like double underscore str double underscore is a built-in, double underscore dot double underscore is a built-in. That's another built.
so basically it's wrap stream.
Rep for representation. The difference underscore str double underscore and double underscore retr double underscore r double underscore, as I understand it, is one of precision. Double str double underscore the Python string is meant formal characterization of the object. The repr double underscore should give a precise characterization, if at all possible, when you repr on an object.
And I understand that the wrapper is the inverse operation of the eval. First step is from the living
If you do it properly, if you implement, you can implement repr any way you want to. But my understanding of the thinking is that repr should be the inverse of eval. If you coded repr correctly, and your object does not have any internal code as state. It's a good question. Does my explanation make sense? John, further questions as to where we are. Do you have any questions? Bob, any questions? Okay. So this example, first example, my example really of a non-trivial class, and non-trivial classes, and it combines a bunch of things, including the idea of a nested class. Together, this particular set of things together for a lesson wanted to show the nesting of classes. I also wanted to show multiple inheritance. So first class called card values. Ace, king, queen, jack, 10, down to 2. I have a complete function where two sets of values are equal if they're the same length and they have the same members. I have where I assume that the cards are listed in order of rank. I'm also assuming for this example, my suits are independent of my values. Not for all card games. There are a bunch of crazy card games in the upper Midwest that came over from Germany, like Euchre and I don't know what others, where you have the left bower and the right bower and the suits mutate. And, okay, this for example does not work for the Mooney Bin card game. It, however, works for card games where the suits, where the orders, the ranking of the cards, and the ranking of the cards is consistent across the suits. The variety of the ranking of suits, and you have cards within the suits. And it would be bridge, where of the suits, the spades, hearts, diamonds, clubs. And within every, you have a ranking of cards within the suits. So what I did, produced a class that captures the ranking of values, a class that captures the ranking of suits, and a card deck. The card values with your suits. With the deck, it's ordering on card values, it's ordering on suits, with a bunch of card objects. Card object. Card object, with respect to a deck, is a suit and a value. Comparable if there's the same deck and suit. And they have values. And then there's a technical quality, a couple of for card ordering, and then the class has suit is value, get card, card deck. Are the decks the same? And do two cards within the deck outrank one number? And that to reference a class within a class, use dotted notation that uses any other entity within a class, any other property within it. So what I'd like to do, so I pulled this out of my hat, it's broken. I'm hoping I finally got it right. I'd like people to do is copy it, make copies, make sure that my card suit, card value, card deck class is low, to see if the operations on cards work. But give it a try. You can see that I can say get the ace of spades from my deck, get the two of spades from my deck, get the ace of clubs, and see if you can compare. Good. Ace of spades is greater than two of spades. They're comparable because they're both in spades. But the clubs is not true as well. I ought to redefine my order to say, at this point, I'm only comparing within suits. If I could change my definition of card comparison to say outranks I'm just saying suit, and card value outranks the card value. What I could say is return card suit outranks card suit, or the value, or the same suit and value outranks the other. For the class, right? Okay. So this particular code, I mean, is more of a reference. Go back and look at it if you ever think you want to do something this complex. I really like the idea of being able to hide functions within functions and helper classes within classes, because it really, to me, describes what's going on with the model. A card has no meaning outside of a card deck. Therefore, a card cannot be a top-level class. Okay. Ryan? Questions?
So the advantage that the card values that ace, king, queen, jack, they will be passed between your methods. Really, you can inherit from the card.
Well, where the values are referenced. Here's how I write it. I have a value function that returns out a set of values. Excuse me. I have a value that returns a set of values. Here, if I it's values within the deck.
Wait. So that you can store those values in the card value and then
Right.
how much is that? The best is
Well, I use defaults. I use defaults. If I wanted to use something other than defaults, what I would do is have to specify. Well, values equals none.
Yeah.
If I want to specify the values, I'd have a value. I change the values parameter here. I can like ace, king. If I want two cards in my values, if I want two suits, like say swords and swords terror deck. I'm trying to think of what the other suits are in terror decks. I don't remember any offhand. Pentacles. Okay. So if you have a deck of 4 cards, an ace of swords, an ace of pentacles, a king of swords, and a king of pentacles, that would give that to me. If I wanted to do 2, but I wanted to just have swords and pentacles, I would need the way that this particular logic is set up to do something like I'd have to re-enumerate all my values. Ideally, I simply wanted to change the values independently of the suits, or the suits independently of the values. Instead of having a list of conditional parameters for card deck, what I would do, I would set up something like instead of values none, suits none, I would set a keyword parameter. And simply check for values keyword and a suits keyword, and default on the values keyword and the suits keyword. In making is that question?
Yeah.
This example is simple. Is that I haven't tried to change the suits, but I could do that. If in probably that particular example, a couple more, I could work on refining these examples, and that might be a good thing, but I'm not going to do it here. Instead, the last topic in month or late, and then show you a couple sample codes. And we'll close out the day with that, and I'll put together uniform modules and for next week, and that will wrap everything up. That'll be a wrap on the Python. Okay, so iterators. Here's Fibonacci. Yet another way of doing Fibonacci. Okay. To graph line 26 through line 27. Run the animals. See how they look. And so what is there? People seeing what I'm seeing. On what I'm getting. People getting what I'm getting on one example on the screen. Okay, so this example, right? Are you getting chip one? The point is that iterators remember where they've been. So you poured all the water out of the bucket, and you keep trying to pour stuff out of the bucket, and nothing comes. It's because you haven't refilled the bucket. Into this particular glitch, when I started coding with it, it was like, oh crap, what did I do wrong? Well, what I did wrong was I failed to code in a way that allowed the content to be reset and gives you, if you use it, then Python will get it. Find something called next. The first through a generator, Python will hit iter, and on successive occasions will hit next. So the concerns, the iter practices use iter to set up the beginning of your iteration and to use to produce values. And what you see, if you use example 4050 through 4069, is code unlike the first one would be like finding keyboard. So, which means that I think edit.
Yeah.
John? Bobby? Ryan? Shaquan? Okay.
The question.
Yes.
So if I want, can I use there something to check out this? Just,
DIR, you could use something like print. Let me see if I can gen iter doc. No, there's doc. Now let's see if I can put object. No, is iter is a user-defined method. You define iter, and the is the for loop in Python goes to whenever it tries to an object for values. If you have a for in or a while, X for in, the beam is for looks for in. So iter is not. Let's see how it's a dog. The for language construct. For is not a function. For is part of the language, and you cannot. It does not have a docstring because it's a statement rather than an object. Learn about iter. There's no way to say print a docstring for for. If I wanted, when I define this code, if I wanted to add a docstring underneath double underscore iter double underscore, I could do that. I could, let me see, now, but again, the iter and fit, iter dot, I'm not going to get it. It's taking time to define docstring for iter.
Please find the iter yourself.
I define iter myself. It's not a built-in. Once I find iter, force recognizes iter. To learn more about double underscore iter, I would go to the Python library and I would look up for statements, and I would also look up double underscore iter double underscore in the library reference. But it's not an object. A statement is not an object.
Kind of like we fell between paths in my holy state. Or something like 2 weeks later, and I forgot.
That's why there are two things. I put out a bunch of examples, and this would be to go for the Summerfield book I've recommended, or the book I've recommended, and go to the index and look up it. Both book and the Summerfield book have good treatments of iterators. I learned what I know about iterators from reading the Summerfield book and going on the Python website, reading about iterators. So, Learning Python, Volume 5, the Summerfield Python 3.0 are two references. And getting typically somewhere in excess of $1,000 a year on references, including some of which I've never opened. Unfortunately, my list of things to do has changed, or anticipating maybe I have to do doesn't happen. And I've also moved of these old references. I still have my COM library, for example, my DCOM library, most of that. So, but that's what I do, Shaquan. I buy books, keep the book companies happy. Okay, let me show people one more example of a little bit of elegant Python to close this out. How many people are familiar with Conway's Game of Life?
What?
If you're not at Conway's Game of Life, you will see it today. This example that turned the head of one of my colleagues. This particular code takes a lot of time to write on in language like Java. This is game of life and life. So like, first of all, copy lines 42, 46 to 42, 67, and run it. And it'll describe what's going on once you've had a chance to see it. Huh. Okay. No, you have that. That's right. I'm sorry. Oh crap. Well, let me see if I can get this thing to run. Maybe let me. Oh, okay. Let me do this first, and now I'll show it to you. And I'll explain it. Okay, so oh, I see. Okay, indentation errors. So let's wait. This is what I want to try. Be part of my final notes. Get this. Probably need to bring this down. Let me kill this. And it's sort of printing out. I saw that nut. World. Right. I think. Oh. Okay. Let's see. I wanted to bring this down. Properties. Font. Take it to like 8 by 12. Okay. And reset the window. To 100. And I'm not sure what non-stop is coming on. It shouldn't be. Print. I think world. Okay. Okay, this is do with it. I'm sorry, another while all the nuns are. Ignore the nuns at the bottom and hit the progression of the symbols on the screen. If you haven't seen Skate with Life, it goes back to the 1950s, where a mathematician, I forget Conway, the 50s or 60s, a mathematician named Conway, back when people were just starting to play around with chaos theory, maybe a simple sets of rules leading to complex systems, came up with a set of rules that said that if a cell has, I think it's 2 or 3 adjacent occupied, then reduce it that doesn't have stuff in them, then it persists as it goes away. And if you run this, this is not, let me get a different starting configuration. Port random time. See if I have a different configuration, I have a different random here. My red's going with the random number generated. It's not doing. And let's say 0 to random 7. Let's try that. See what we get. It's interesting. Okay, more interesting. Notice how cells are evolving and different patterns are. It's interesting about this particular recursion is that there is really no closed form solutions with, even though the rules for the stop mutates are fairly simple. So fairly simple. Here's the Python expression rules. I'll run for a while. We'll see what happens to the pattern. So the way the game works is, first of all, you see the world. The world is some sort of a grid. For example, here I'm setting up as a 50 by 50 grid. And you put things down. You have rows. Well, this is a row, and then these are the columns. Generate a new world. And then the rule of survival is if you're next to 3 cells that have stuff in them, or if you are occupied, have 2 other cells occupied next to you. In other words, if you have a group of cells and there are 3, then the value persists. Other is going to rule. Get, and then there's one function that number of cells around you. How many cells are around you? Well, you take the array, and you take I and the j coordinate, and this must allows for world wrap, like the old Pac-Man game. Whenever Pac-Man would go off at the end of the world and come back around. I saw a cartoon the other day. It's the 4. It's the 4 blobs used to chase Pac-Man from the old Pac-Man game. It's a cemetery. And there's a gravestone. All of it. Vince is in here. Okay, there's a gravestone. There are 4 blobs, and one of the blobs saying the other blob. I don't even remember what we were fighting about it. So the point of this example, if you haven't seen Conway's Game of Life before, and it looks like nobody in the room has seen Conway's Game of Life, the point of the example is kind of lost on the audience. So yeah, it used to be a screensaver, but the point is that you can do something in Python with generators, with the very Python idioms that would typically take 2 pages of code to do in a language like Java. Whenever my colleague, Dr. Jeff Roach, who used Game of Life and his programming tool, saw this and said, "Here it is," he kind of. So I've been self Python as an introductory language in our department. I think Jeff I've sold Jeff. His comment is we would need to run a CS1 that used Python instead of in order to make it fly. And I'd be happy to do it, only I'm hooked up with other work, including, I hope, what will be a grant with Nix if we can ever get this thing written, right?
Yeah.
So I think I really ought to do in this series, again, is modules. And I'll try to cook something up for modules next week, and then we'll close it out with modules.
Sounds like a plan.
And anybody have any questions about what I've shown here? For examples that will show up at the end, these concluding examples. We ran a percentage example in class. We did stupid simple prime generation in class. What I think is really cool about that is that this particular, it's an S-squared algorithm, it's a bad algorithm, but this generates all the primes up to a certain number. This is one expression. Example, I did sorted class. I did this one for Shaquan. Bobby, Patty, Dave, John, Ryan, thank you.
Thank you.
One more week.
One other suggestion is, for example, how to use Eclipse. You step through. Separate.
And I would be doing that. The term of service here is shrinking, however, and I have a nature proposal to hope that I would say the first perhaps be your fearless leader.
Smelly feller. I can do some. I was looking on the web. Python or all set up. Yeah.
So Eclipse and thinking is the way to go.
If you use it here, you can see